All right, chapter 9 to 11 review. I'm going to start off with chapter 9. Some of these are from your textbook here, McGraw-Hill Ryerson, Pre-Calculus 12. Some of these are from the 9 to 11 cumulative review. Some of these are from just chapter 9 review, 10 review, 11 review, whatever. We're covering chapter 9, 10, and really just 11.3 in this review. Just a brief overview of combinations from chapter 11 in this review. Okay, so chapter 9 was talking about rational functions. Rational functions, of course, are functions that include a polynomial on the top in the numerator and a polynomial in the denominator. That's the big thing. There's an x in the denominator, okay? So that's something new. We also did transformations of these kind of functions. So a 1 over x graph is simply, a 1 over x graph. Okay, so if we make a quick table of values, we'll do that really quickly, x and y. So if we have a negative 2, y then is 1 over negative 2, it's negative 1/2. 0, 1 over 0, oh, that's a problem, right? That's undefined. That's going to be a vertical asymptote, isn't it? Because x cannot equal 0, it's in the denominator. If we do 1, 1 over 1 is 1. If we do 3, 1 over 3 is 1/3, and so on. So we could put a lot more points in there. We don't really have to. A couple things that we know would be that when x is negative, y is negative. Okay? The greater that x is in the negative direction, the closer the y values are to 0. So it kind of looks something like this, right? And then here, the closer that x is to 0, the closer the value is to infinity. 1 over 0.001 would be, like was that 1,000? So it's really, really great here. So it kind of looks something like this. So that's your 1 over x. We did talk about transformations there. An a value here, an h value here, a k value here. We didn't worry about b values. It was too confusing with this, so there's no b values, just these three that would shift or stretch the graph. Okay? So this a value of 2 means that every value gets doubled. Every value gets doubled. If it's small, then doubling that doesn't make it that much bigger, but every value gets doubled. So that's the stretch, right? So here's what the new stretch would look like with a 2 there. And with a 2, everything gets stretched up a bit. Okay. This minus 1 represents a shift, a horizontal shift, because it's in with the x, right? It's added or subtracted to x. That means it's in the x direction here like this. It's shifted. And of course, if it's a minus, it's shifted 1 unit to the right. So this graph, this blue graph, I don't think I'll be able to isolate just the blue graph. But this whole blue graph, forget that. I'll make it light blue now. Everything's going to get shifted over 1 unit to the right from where it was before. Okay, that means our vertical asymptote is at x equals 1 as well there. Okay, and then finally, this 3 is a vertical shift, a vertical translation. So it either goes up or down. And in this case, it goes up 3 units. It's a positive 3, goes up 3 units. So this light blue graph then would go up 3 units and would look something like, this, right? So here's our new graph with our asymptotes there, and transformations of rational functions works the same way as transformations with other functions, okay? Any questions about that at all? All right, domain and range, intercepts, that sort of thing. Intercepts are easy. If you want to find the y-intercepts, let x equals 0, solve. If you want to find the x-intercepts, let y equals 0, solve. Domain, okay, wherever the vertical asymptote is, that is restricted for the domain. So here the vertical asymptote got moved over 1 unit. So x cannot equal positive 1 for the domain. X can be anything but positive 1. The range is where the horizontal asymptote goes. So it's always at y equals 0 unless it gets shifted up or shifted down. The range would be all values for y except for y cannot equal whatever it is that the horizontal asymptote is. All right? Any questions on that? Okay. So I'm kind of going through this pretty quick because this is just review. Certainly if you want to refresh yourself on any of these videos, go to mrmathwell.com, look up your course, look up your chapter and videos, they're all up there. All right, number 4 here, again, this is on a review somewhere, solve algebraically. Got to know how to do this for sure. first thing you want to do is probably factor both the tops and the bottoms. Usually the bottoms are the most important. If you factor those, just so you see what kind of factors you have. So this x squared minus 9 is a difference of squares, so I'm going to factor that. And I see that I have two kinds of factors in the denominators here. So to solve algebraically, you want to eliminate the denominators by multiplying by the factors that you see in the denominator. So I am going to multiply this whole equation by x plus 3 because I see that right here and right here. And I'm going to multiply it as well by x minus 3 because that is a factor that's in the denominator as well. In doing that, you will be able to eliminate the denominators, and it'll just be a collection of terms like a polynomial. You'll be able to solve for x for however way you think you can. Please note that x cannot equal here plus or minus 3. So before we get rid of these, please note there are restrictions on this question. Okay, so might have to keep that in mind. So this is going to be just a 1. When I multiply these two times this one, the x plus 3s are going to cancel out, so this is just going to be x minus 3 left on top. And of course, anything times 0 is still 0. So this one simplifies to something really, really nice and simple. I'm going to solve for x here, and I'm going to subtract 1 from both sides. I'm going to add 3 to both sides. So x here equals 2. There's just one value that I've gotten for 2 in solving here, for x. And it's not one of my restricted values. Still though, I should always check. It shouldn't take you too long on your tests to check. I would encourage you to check every question. If you feel like you're going to run out of time, then I would say go back to check. Okay, get an answer. If you're not going to have enough time, even just do this. Say check, leave it blank, so that you know to come back to it if you have any time. Okay? If you do all your checks and run out of time and you don't even get to start 1 or 2 questions, that's a big deal, right? So at least here, even if you got this wrong, you didn't check, you'd get a 3 out of 5 maybe. If you got this totally wrong, you get a 3 out of 5 maybe for all this good work. Okay? You check it, you realize you're wrong, you fix it, you get a 5 out of 5. But, you got to make your choice. So a check would simply be, 1 over, let's put 2 in there, so it's 2 squared minus 9. And you can do this in your head, really, too. A lot of this in your head. I'm writing all this out so you can see what I'm doing. But, 4 minus 9 is what? 4 minus 9 is negative 5. That's a 3 here. Plus 1 over 5 equals 0. That is totally true right there. Okay? 1 over 5 minus 1 over 5. That's what that is saying. So there's your answer. Now that's algebraically. I'm not planning to do graphically, but of course graphically, you have 2 options here to solve, because you need to know how to do that too. And how you would do that solving graphically, one option is to change this 0 into a y and graph this on your graphing calculator. Then you find the x-intercepts. And those x values, or value for the intercepts, would be your solution or solutions. Okay? The other option would be to take one of these over to the other side. That would make it a negative. And then you do y equals this one, and y equals this one over here. And then you find the intercepts where those graphs would cross each other, and then that x value would be your solution. In either case, in this case, you would have a x-intercept of 2, and we should get that. If we have time, we'll do that later. Any questions about graphing or solving algebraically there from chapter 9? Okay. What happens if you have a question like this? I didn't find one like this, but I thought I'd show you one like this. What happens if I say, hey, here's a graph, but there's an unknown part to that graph, but I'm going to give you a point that's on that graph, and please solve for k. What you need to realize, and the reason why I put this on here is because students would look at this and say, oh my goodness, look at all these unknown variables. I don't know what to do. How do I solve? Well, this is your x, this is a y that you know are on this graph. So you should just substitute 2 in for y and 15 in for x. Then you can solve for k. So please remember that it is as simple as something like this. So this would be the vertical translation, right? How high up or down should you move so that this point that I'm giving you is actually on the graph? Well, let's just solve. It shouldn't be that big of a deal here. 2 equals 2 over, what's 15 minus 3? That's 12. So plus k, all right. That's a 1 over 6 if that matters. You can multiply everything by 12 to get 24 equals 2 plus 12k. Okay, make sure you multiply everything by 12, each single term if you're going to do that. And let's subtract 2, so 22 equals 12k. Looks like here k equals 22 over 12. We'll simplify that to what? 11 over 6? So that would be our unknown k value. That's how much you'd have to move this graph upward in order for that point to be on that graph. Questions about that? Okay, so I graphed this here real quick, and here's k. I can move this graph up or down with k. And what was that, 11 over 6? So that's just under 2, right? That's 1.83. So 1.83 or so. So 15 and 2, here you go. So look at that. It's pretty close. If I had that exact, and I probably could just type that in there. What was it, 11 over 6? 11 over 6. Okay, there you go. So now I should have 15, 2. Look at that, is exactly on there. So anything greater or less than that, that graph would not pass through that point. So that's what you're finding. All right, let's move to chapter 10. Chapter 10, function operations, right? Adding, subtracting, multiplying, dividing. Remember, dividing is really just rational functions we studied in chapter 9 for the most part, right? You have function divided by a function, rational. Composition of functions too, like where a function goes inside another function, another thing you need to be aware of. So, consider these functions. What I'm going to do is I'm going to say, hey, let's do this. What does this notation mean? What am I doing to these two functions if I write this? Yeah, I'm adding f of x and g of x together. So I've got root x plus 2 plus x minus 2 as a second function. Simplify that. I simply have root x plus 2 plus x minus 2. No like terms together. I'm done. Okay. Okay. What about g over f of x? That's a division, right? That's a like a rational function. So I'll put g on top. So that's going to be x minus 2 over root x plus 2. Please don't do this. I will cry. Literally, I will cry if you do this. I'm like, hey, yeah, the answer is negative over root plus. Please don't do that. I seriously, I will probably slam my head against the wall and cry. And if you want me to slam my head against the wall and cry, please don't do that. Just tell me, and then I'll just be mad at you for a little while. Okay, but don't do that.
Actually ever done that?
Has anyone actually ever done that? What, do this kind of thing?
No, done the negative over square root of.
No, I don't think I've ever seen that exactly, but I've seen something very close to that. Yes, like I've seen the numbers all go away and signs be left. Yeah, I'm like, are you serious? Yeah, like you're gonna show me a 1 over plus. Okay. Okay, you have not been listening, or I am a terrible teacher and I didn't realize that. There's one of those two is the exact truth. Okay. So we're not doing that. We're not upsetting your teacher this way. That's fine. Okay, what about this, guys? What about f of g of x? That looks really tough. G of x goes inside f of x. Yeah, quick question?
Do you want us to leave the root in the denominator?
Oh, in the denominator? Yes, it's fine. Well, don't worry about rationalizing the denominator right now. No, I'm not worried about that. So yes, if the question said, make sure you simplify. So simplifying, technically you don't want any radicals in the denominator. You would multiply top and bottom by root x plus 2, which you've done that exact sort of thing in chapter 6, right? Proving identities and all that. Multiply by the conjugate, remember that? So you can multiply by root x plus 2, and that might be your final answer, but I'm not going to worry about that right now. But great question. Very, very good question. Okay, so g of x goes inside f of x. Watch this. F of x is the outside function. Sometimes I like to write the outside function first and then just leave space for the inside function. See, that's f, right? And inside is going to go what? X minus 2. Now this one we certainly should simplify because this is begging to be simplified, right? If we can get rid of brackets and unleash the unlike terms or the like terms here, that's great. So this is going to be just what? X plus 2 minus 2. Huh. Just root x, right? So that would be your simplified version of that one. Isn't that great? Yes, great. Isn't math amazing? That's so fun. Root x, wow. Okay. Now there are others we could subtract, right? We can multiply, no big deal. But let's move on to this. What happens if we have an actual number inside here, f of g of 2? Remember what we do here, anybody? Where do I start?
You solve with the inner part.
Yes, I solve the inner part. Yes, thank you. Evaluate g of 2. We want to evaluate g of 2 first. So I'm going to go f of, what's g of 2? Well, g is absolute value of x. So guess what? That is absolute value of 2, which is the same as just f of 2, isn't it? Okay, what's the absolute value of 2? Yeah, it's just 2. So what's f of 2? Well, that is when 2 gets put in for the x in the f function. So f of g of 2 is actually 4 minus 3, or 1. So let me know if that makes sense to you, or if there's anything that does not make sense. Yep, you evaluate this g of 2 first, which I did here, absolute value of 2, which becomes 2, and then I put it into the f, and then evaluate that. Yeah, if there's a third one, then you put that answer into the next one, and you just keep working your way out. Start inside, keep working your way out. Put the answer into the next outer function. Answer, next outer function. Answer, next outer function. That's right. So this one, notation, remember this, f circle g, or this is f of g of 2, of negative 2, sorry. So g of negative 2 is actually absolute value of negative 2, which is 2. So now I put 2 into what? F.
So
So-
you're saying that that little circle just means up?
Yeah, pretty much means f of g of 2. Yeah, that's right. It's literally the same as this. It's the exact same. It's the exact same. So f of 2 is 2 squared minus 3, also equal to 1. So f circle g is, as a matter of fact, just another way of writing this. Although these are the same, but we have different values, they still do turn out to be the same value, though, because of the absolute value. All right, any other questions about that one? Yep. So yeah, your question is, like, can you, instead of doing the 2 right away, can you just do f of g of x and then find out what that is first? So which would be like absolute value of x squared minus 3. And then do your, whatever your value is. You can, totally. A lot of times, though, doing that first step is going to be, this is going to be more difficult than just evaluating g of 2 first. Right? Because if you have some crazy stuff there, getting that simplified or right, you're going to have x's all over the place. And so usually it's just easier to evaluate the first one first and then plug that just number in. That's usually going to be easier, but yes, you totally can do it the exact same way because it still gives you the same number. All right, good question. All right, let's move on to chapter 11 here now. Okay, NCR. Now, 11.1, 11.2, we just took a very cursory look at. We did not focus a lot of time on 11.1, 11.2. The combinations and permutations, did not spend much time on that. What I want to focus on here in this review is NCR, because that's important for 11.3, Binomial Theorem. Remember, NCR is finding the number of combinations of, in this case, 3 things given 7. So n is the total number of items. So n is total number of items for objects or people or whatever in the question. R is a subgroup, so a subgroup of the total. Subgroup of total. So questions that could be answered using this combination formula would be like, if I have 20 students, how many different combinations of 3 students could I choose to come help me do something else? Well, it would be, what did I say, 20? 20, choose 3. Right? So how many different ways could I do that? How many different groups of students could I do that? And the big thing with combination is the order doesn't matter. So the way that you come out the door, if you come out the door differently a second time, it doesn't matter. It's still the same combination. The order does not matter. Now, this whole thing here, okay, how do we actually do this? The calculator does this for us, yes. But what is the calculator doing? You need to understand that, okay? You take the total number of n items, and do you remember what this little sign is called? Well, it's an exclamation mark in English, so you say something with enthusiasm, but it's factorial in math. And what factorial means is you multiply n times every successively smaller whole number until you get to 1. So n has to be a whole number. Negatives don't make sense there because we're talking about a number of items, so not a negative number of items. It has to be a positive number of items. I'm not talking about decimals, okay? We're talking about whole numbers. Multiplied by 1 less than n, and then 2 less, and then 3 less. So 1 successively less whole number until you get down to 1. That's what factorial means, and that is key. We didn't have time to go over that a lot, but that is key in figuring out how many different arrangements can be made with, if you have a certain number of things, how many different ways can those be shuffled around and put in different orders. That's where that comes from. Okay, we take that total number of specific arrangements and we divide it by, and again, why, don't worry about it. But what we divide by is the difference between n and r factorial times r factorial. So if I had 7 people, let's say, and I wanted to choose 3 of them to run an errand for me, in order to calculate that, I would take 7 and I would do factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. And I would divide that by the difference between n and r. That's 4 factorial, or 4 times 3 times 2 times 1. Multiply that again by 3 factorial. That's the r, 3 factorial, or 3 times 2 times 1. Now these are all factors, so we could actually do something quite fancy, I think. That cancels off with that, divides out with that. 3 times 2 divides out with this 6. So guess what? This answer is 7 times 5 divided by 1, or 35. So there's 35 different ways you could choose 3 people out of 7 to run an errand for you. Just 3 different groups. Wow, I see some shocked faces. Did you think that what I did up there was really cool? All right, yeah, that is cool, yeah. That's cool, isn't it? Yeah. Woo! Right on. See, that's why I teach, those faces, like.
Usually you're not allowed to just cross things out.
What do you mean usually you're not allowed to cross things out? Sure, if they're factors, you can.
Yeah,
Factors. Sometimes.
Well, you wouldn't let us cross it out and just leave it as.
Okay, yes, it's right. I would not let you do that up here, like the x's, you can't do that up here. No, because they're not factors. Because this is x minus 2, it's not x times 2. Yeah, I know, details. Yeah, small details, fine. Okay, now the importance of this combination for this course, it's most important because of the binomial theorem. That's the only reason I think they bring it in here, because of the binomial theorem. Now, if we were to look at the expansion of a binomial, or in this case, determine what a numerical coefficient is of a certain term in this expansion, I would want to focus on combinations to do that. You do not want to write, you don't want to draw like 5, 6 rows of the Pascal's triangle. It's going to take you too much time. Instead, we'll focus on combinations. So the triangle looks something like this. I'll just draw a few rows, right? Right, 1, sorry, wow, going too fast. 2, thank you, 3, 3, 1, 4, 6, 4, 1, I'll stop there. But those are the rows. The exponent is 5, that's pretty small. But rows of Pascal triangle, okay? Now, remember what we also did was that this one here is, what was it? What did I start with, 0? Choose 0? This is 1, choose 0, and then 1, choose 1. This number over here is 2, choose 0. Then this number is 2, choose 1, not chlorine, choose 1, and 2, choose 2. And so on. So in the 5th one, notice that the second row starts with a 1, the third row starts with a 2. So in the expansion, this is a plus b to the 0, this is a plus b to the 1, and so on. So look at this. This exponent is going to start off with the same number here for the coefficient in that row. And again, this is just a review. Hopefully some of this is coming back to you. But I'm going to start with 5, choose 0 is going to be the first coefficient would be in Pascal's triangle to match with this. Now, what's the fourth term? Okay, so it's going to be, this is first, this is second, that's third, that's fourth. So 5 choose 3, is that what you said? Nice, okay. So the fourth term is going to look like this. 5 choose 3 is going to be the number that's going to be in front. Now, remember also what we do here is with the a's, this is going to be 5x to the 5. That's the way that's going to start. Then this is going to go 5x to the 4, then to the 3, then. So we also have 5x squared as we work the exponents down. The last one, y, this is going to be y0 on the first term, then y1, then y squared, then y cubed. So the numerical coefficient, now why am I doing all of the whole term? This is the whole term. When I simplify this out, expand it out, the numerical coefficient is actually going to be, it's going to be part of this, 5 squared, and this. It's going to be the multiplication of those two. So I do kind of have to go beyond just the number in Pascal's triangle here. So this whole term, 5 choose 3 is going to be what? 10? 10 times, this is going to be times 25x squared times y cubed. So this is 250x squared y cubed. That's the whole term. So my solution here, the numerical coefficient is 250. Okay, just one more example from 11.3, binomial expansion. This is pretty huge. You got to know how to do this. This is the bulk of our learning here. Okay. Now this could be to the power of 3 or 4 or 8 or whatever. Like on a test, I probably wouldn't give you to the power of 8. That's going to be a lot of terms. Probably wouldn't do that. So just so you know, I'm not going to give you that one. But the process is the same. Okay. So if this is 3, which combination am I going to start with? We just talked about this. What number goes here? That's right. So it's 3. And it's going to be choose 0 for the first one. This is going to be 2x, which is the first term, to the power of what? 3. Good. This is going to be negative 1/3 y to the power of 0. And that's just going to be a 1. Anything to the power of 0 is 1, as long as it's not 0 itself. So that's my first term. I'm going to simplify that in a bit. Let's move to the second one. I've now got 3 choose 1 as a coefficient there. I've now got 2x squared as I move one number down from my exponent. And I've got negative 1/3 y to the power of 1. 3 choose 2. 2x to the power of 1. Negative 1/3 y squared. Finally, 3 choose 3. 2x to the 0, and yes, that could be just a 1. You don't have to really even write that, but probably a good idea to show all these terms, right? So I can see what you're doing. Negative 1/3 y, and that's going to be cubed. Another thing to remember is that the sum of these numbers here should add up to your n value there, whatever that is. So 2 and 1 is 3, 1 and 2 is 3, 0 and 3 is 3, and so on. Okay, any questions so far as I move to the next step here? So now let's simplify. You can take 1 line to simplify, 2 lines to simplify, whatever you think you need. 3 choose 0 is just going to be 1. This is going to be 2x cubed is 8x cubed. And then just times a 1 there. 3 choose 1 is going to be, what's that going to be? What, 1, 3? That's going to be 3, of course. This is going to be 4x squared times negative 1/3 y. That's what that is to the power of 1. 3 choose 2 is also 3 times 2x. I would simplify this probably right now, which would be a good idea. So that's going to be positive because it's squared. 1 over 6 or 9? 1 over 9 y squared. Plus 1 times 1 times negative 1 over 3 cubed is 1 over 27y cubed. So simplifying this, I have 8x cubed is my first term. I'm going to have a minus here because I have a negative here, so that's going to be, and the 3's are going to cancel out or divide out there. So I'm going to have minus 4x squared y. I'm going to have plus 3 over 9, that can be reduced to 3, so 2/3 x y squared. And you can put the x and the y squared on top all over the 3 if you want. And then I'm going to have minus 1 over 27y cubed. Now, if you have any like terms, I don't think you should, but if you have any like terms, you want to gather those. Anyways, how does that look to you guys? That's your 9 to 11 review.